and welcome to our team's presentation, where we will present to you Climate Collective, a Red Cross initiative to mobilise First Nations peoples as citizen scientists to collect valuable data and insights to champion the fight against climate change. Our team consists of Caroline, our product owner, who sets the product vision and works closely with the development team to ensure delivery is aligned with what the end customer wants. Our developers, Jessica and Andrew, overlook the execution and delivery of the mobile application. Evelyn is our UI/UX designer, who led the design process, creating low-fidelity prototypes to ensure the most seamless and pleasurable user experience. Our team of business analysts, both Grace and Jeffrey, heavily engaged in market research and solution design, and also supported the development and testing of the product extensively. Finally, I am the Scrum Master, the servant leader supporting the development of the team by removing blockers and ensuring we are upholding Scrum values and best practices. Today, our team will go through an exploration of the problem domain, a deep dive into our discovery phase, present our solution and implementation plan, and conclude on our project reflection. I'll now pass on to Caroline to discuss the problem domain.
The current problem landscape shows there's been over 50% loss in global biodiversity over the past 12 years to climate change. We conducted a root cause analysis on the problem, being a lack of effective solutions for First Nations people to provide data on the experience of climate change. We identified a key notion being that First Nations communities share their knowledge and thoughts in private and culturally safe settings. Based on the 5 whys analysis, we formed the problem statement being, there's a lack of knowledge being collected and shared about the Indigenous experience. This paired with the rising social, cultural and ecological impacts of climate change emphasises the need for an accessible digital solution to mobilise First Nations peoples as citizen scientists to empower their voices, preserve their traditional life, and meaningfully address climate change. It is important to solve this issue of a lack of data. There are 2 key pieces of data that need to be collected, which is Aboriginal people's thoughts, feelings, and observations, and their knowledge of climate change adaptation. Firstly, we need to collect Indigenous people's thoughts, feelings, and observations on climate change to help address the impacts of climate change on their lives. As seen below, climate change has impacted the social, cultural, and ecological facets of Indigenous peoples, a key issue being the loss of connection to land. Secondly, we need to collect Indigenous people's knowledge on climate change adaptation to enhance climate change solutions. For example, local Aboriginal people's knowledge on customary fire helped reduce 450,000 tonnes of carbon dioxide from wildfires in West Arnhem Land. Our evaluation of existing solutions shows there are key issues that can be addressed through innovation. Firstly, Australian citizen science mobile apps aim to address climate change, such as Climate Watch and RedMap help monitor rainfall or marine life in Australia. However, these solutions are localised and siloed as they only address the ecological impact of climate change in Australia. Thus, our solution will transcend Australian borders and capture all climate change related issues, including the social and cultural impacts. This will be done through social networking and data sharing between First Nations peoples and non-First Nations communities to empower their voices and effectively address climate change. Secondly, a conference called the National First Peoples Gathering on Climate Change in 2021 saw Aboriginal leaders and climate scientists discuss Australia's climate change response. However, this discussion excluded First Nations people who are not leaders to express their concerns in an ongoing discussion with others. Hence, our solution will empower all First Nations peoples as citizen scientists and create a community that facilitates an ongoing collaborative discussion with real-time data from user-generated content. Our project aims to mobilise First Nations peoples as citizen scientists to provide valuable crowdsourced data about the social, cultural, and ecological impacts of climate change by collecting 2 key things. First, the thoughts, feelings, and observations, and second, knowledge on climate change mitigation and adaptation of First Nations peoples. Collecting this data will empower First Nations people's voices, preserve traditional life, and address climate change.
Now, moving on to the discovery phase, we created a user story and the user journey map to aid in empathizing with our end users. These tools help us etch out what our potential end user could look like and what type of features that they might use. Here is Stephen, a 52-year-old First Nations person that believes his traditional knowledge of the land and customs could aid in the fight against climate change. Now, he is looking for an accessible platform to share his thoughts. So what does Stephen expect from such a platform? This question forms the basis of our acceptance criteria, which are the technical requirements in order for the user to intuitively navigate the app. For example, a newsfeed feature should display posts in a logical order, such as by date, which will form our positive test case. However, if it appears jumbled or unorderly, then that will form our negative test case. Personally, this is my favorite part of Agile, as we really get to put a face to our users and deep dive into the human aspect behind the software we're working on. Continuing with our Stephen, the user journey map visualizes all the key functions such as creating a post or signing up with an account, and we map that according to the release cycles of our software based on their level of importance. This then forms a roadmap to show that the development of our product is directly in line with the needs of our users. And now we move on to our solution.
The solution that we've built is a mobile application, and it's really looking at collecting and sharing knowledge between First Nations people on the issue of climate change. So it has 4 key areas: data collection, discovery and sharing, data analytics, and security. So when a new user enters the application, they have to create an account through the Firebase authentication system. Next, they need to accept the terms and conditions. So this is really important for us for transparency on what data we're collecting, how we're using it, and what conduct we expect from them while they use the application. Next, they need to create their profile. So the big thing to talk about here is that we changed the scope of the nationality from just Indigenous Australian or non-Indigenous Australian to a more global, I'm a First Nations person. This was implemented after feedback in our Week 7 MVP. Next, we have some how-to guidelines of how to use the app and what they can do. And then it comes to an acknowledgement screen. So this was really important to warn First Nations people that there may be images and names of deceased people in the application. And then it comes to the home screen. So in the top left, you can access your profile and get some basic analytics. You can sign out, and there's a help screen as well. One of the things that we were going to implement but didn't end up having time for was a chat bot. So this would be a good future improvement to let a user know how to use the application and how to run through the different screens. In terms of data collection, there's 2 ways that our application collects data. The first way is in the new entry. So this is the most important way for users to share their thoughts and feelings of the impact of climate change. So some things that it has is categorization of the specific subset climate change issue. It also allows for a support type to be selected. It also collects geolocation of where the user is submitting the data from. But if they're talking about something that's not actually in the location that they are from, then there's also a drop down for the kind of area or region that the entry refers to. They can also react to their own entry to let us know how they're feeling, and there's a helps page in the top right. The second way is there's a daily poll on the home screen. So at first we were going to have unlimited questions of kind of thought-provoking of how they're feeling about climate change, but then we decided to have the same questions each month, and this was decided because the citizen scientist guest lecturer Michelle Neal said that it was really important to track opinion changes over time, and so having the same questions each month would allow that. We made sure that the data that we're collecting is really structured, so a lot of the input isn't free text, so that we can have clean and accurate data.
Climate Collective displays all user data entries with all important information. We wanted users to be able to express their emotions. Hence, users can react to these data entries based on their current thoughts and feelings of the data entry. Here, it will update this summarizing the 2 most used reactions for each data entry. One of the biggest feedbacks received from the teacher staff during the MVP presentation was, how do we know the data entries posted are factual? Well, this is where we added the validated entry badge that can be validated by scientist users within the app community, such as myself, by simply clicking the validate entry button. Also, upon receiving feedback testing from our BAs, they've suggested adding comments to foster better user interactions and engagement within the Climate Collective community. For example, I can enter in some text. Additionally, the initial vision for the Discover feed was to have a search filter, sort filters based on location and categories. However, this was something we prioritized for future sprints. Instead, we prioritized security and privacy of the app, such as when capturing users' location, we only showed the state and country. Additionally, some challenges we faced was a trade-off between functionality and security, as videos are saved as a link in Firebase. This was a limitation and instead we had to adapt by using explicit intent rather than an embedded video. As mentioned briefly before, only scientist users can validate data entries. However, we also have two other users, citizen scientists and admin users. Citizen scientists are the general users where all users are given this role by default without any access to validating data entries. Originally, users can only be assigned as scientists in the backend. However, as part of the app enhancements, we decided it would be much easier to maintain and user-friendly to have a dedicated app screen where only admin users can see the user list button, so they can easily assign citizen scientist users with a scientist role to enhance content quality control.
Michelle Neal also talked about how important it is for citizen science apps to give feedback to the user on how their data is being used. So one of the things that we decided to implement was an analytics screen. So we have a few different charts here talking about like how people are feeling, what issues are the most important, and what support types are most needed to kind of battle climate change. There's lots of different opportunities for different charts for future improvements and really honing in on different kinds of demographics using the backend data. We also have the chart of the daily poll that is shown after you submit an entry.
During the earlier stages of the application, we knew we wanted to add a gamified feel to the application by rewarding users with coins for creating, reacting, and commenting to data entries. However, we didn't decide what exactly to use those coins for, but through feedback and research in the later sprints, we added a fundraiser screen with extensive validations and exception handling to ensure users can only donate the amount of coins they actually have to their chosen campaign without damaging the user experience. For example, if I select the Amazon rainforest deforestation to donate, here I can see more information, and as well I can enter the donation amount, let's say 2,000. However, this amount exceeds my current coins amount and I should receive an error. Yes, an insufficient amount of coins error. Instead, if I enter an amount that I am capable of donating, such as 50 coins, the donation will go through and it will update the progress bar as well. Additionally, there's more information to those campaign websites, such as the Amazon Conservation here. Additionally, this gamified feature helps incentivize users to continue using the app to not only spread awareness, but actually contribute in solving climate change issues. Additionally, a global aspect of the fundraiser allows other sponsors, so not just the Red Cross, to combat a variety of climate change campaigns across the world. We planned on adding a leaderboard to indicate the most amount of coins donated, but we felt that wasn't a necessary functionality as users are already intrinsically motivated through their donations. Now, if we look at the backend infrastructure of a mobile application, we're using Google Firebase. For authentication, this is used to log in and obviously create accounts. And we also have the real-time database to store any data that's generated because of the application. Now, the parent nodes are stored within the real-time database. So we have the important entities, fundraisers, polls, data entries, and of course, profiles. These are stored in an unstructured manner where users can, depending on users' input, such as, for instance, the media type for data entries. It could be image, could be a video, or could be an audio file. These can be captured quite easily within this structure, and also with comments, because we don't know how many comments there can be. We're able to structure this and store this quite easily within this structure. Now, in terms of security, how do we secure our app? Well, using the rules that are predefined within Firebase. Originally, during development, we used the development rules, so where read and write is just equal to true. This allows us to develop the app much faster and for testing. However, as we progress, and as soon as we were quite comfortable with the application that we produce, we added in more rules to secure the database so that only authenticated users can read or write within the database. Now, there are more rules that we could have added into the app, such as data type handling based on user input. Now, instead of handling that within the Firebase rules, we've handled that within the Java code itself, so we can manage those exceptions and display a custom message rather than a default Firebase error message. Additionally, personally identifiable information such as the names and email addresses are not stored within our real-time database, but it is stored within the Firebase own authentication. So we're pretty confident within our database, our real-time database, and with the rules that are set out here, that no information that's not needed will not be stored. So we only store information that's needed for the application to run smoothly. Additionally, storage stores all our images and videos within the application in a secure format where we have rules predefined as well, that only authenticated users can have access to actually read and actually add those media types within the application.
So we kept a really detailed product backlog throughout the project. Initially it was in Teams, and then we shifted to Jira. In terms of what we implemented, we really focused on 4 key functionality areas. So core functionality, to actually enter in the data into the app. Legal functionality, so terms and conditions. Anything that is for engagement, so discover feed, comments, fundraiser functionality, and anything to give user feedback, so analytics. In terms of what we didn't implement, we didn't implement because of privacy and security risks. So one of the biggest pieces of feedback for us was from the team was sharing entries outside the application, but this was deemed a kind of privacy and security risk, and also anything that was really time intensive or resource intensive compared to the value for the user, so things that were a lower priority. We prioritized using the planning poker method primarily, but also we tried to keep a couple agile principles in mind throughout the application development. So firstly, the first one on focusing on customer value, and the 10th one on simplicity and maximizing work not done.
As you can see, our app features exciting new functionalities that provide an innovative way for target users to meaningfully address climate change. Specifically, Climate Collective gives a voice to First Nations people, non-First Nations individuals, as well as climate scientists, to ensure that the data posted on the platform by citizen scientists is accurate. Furthermore, our solution was developed with current market limitations and opportunities in mind. Compared to current market limitations, Climate Collective has the ability to connect First Nations communities across different countries to discuss a wide range of science topics in a culturally safe environment. Given the app's digital platform, Climate Collective also has the potential to expand globally to thousands of First Nations communities outside of Australia. Finally, we believe that our app generates useful insights to be used as inputs for government policy decisions, to support or challenge the research of climate scientists, and to encourage local activism and community cohesion. As the UI and UX designer of our app, I followed the 5 goals of usability throughout our agile development process, a framework established by design expert Whitney Quesenberry to ensure the user experience of our app was efficient, effective, engaging, error-tolerant, and easy to learn. In terms of the user experience, I really wanted to optimize important factors such as simple navigation, clear and concise content, reduced scrolling, screen orientation, minimizing the number of steps, as well as considering user testing and feedback. This can be seen in features such as the intuitive bottom navigation panel, an interactive daily questionnaire, and colourful analytics diagrams, among other vibrant and consistent features in our app. Finally, when designing the user interface, I developed wireframes incorporating the 10 usability heuristics in order to follow best practice design principles. I also used a primarily green colour scheme with touches of red, as well as modern Aboriginal artworks and photographs to showcase Australia's Indigenous talent and landmarks. You'll also notice that the logo for Climate Collective is the Aboriginal symbol for meeting place, which emphasises the key purpose of our app, to bring people from different walks of life together in order to address the challenges posed by climate change.
Outline is a testing roadmap we adopted during the development of the app. It is comprised of 3 main approaches. During sprint planning, an impact analysis was adopted to consider changes in the code that each feature will require and how this impacts the final app. Hence, features such as machine learning and chatbots were not included because of the complexity of the code, which may lead to many issues with the app later on. Throughout the sprints, user acceptance testing was conducted. Test plans were constructed for each feature, where the acceptance criteria was mapped to their user story. One example of this test, as seen, was that users can upload various media types. Initially, this criterion was failed as only pictures could be uploaded. The feature was then fixed to accept videos as well, but this did lead to a change in design for the Discover feed, which was also tested for user acceptance. Lastly, the final application was tested by exploratory testing, which meant users could navigate the application freely in a non-scripted manner to find applications which break the app. This mimics possible customer interactions. There are many risks associated with the launch of the app to the public. Namely, there is a concern around a lack of user engagement. This can occur due to a lack of customer expected features or no incentivization in the app for users. By conducting backlog grooming, which was influenced by extensive empathy and stakeholder mapping, we prioritized the features that were implemented in each sprint. Here, we saw the need to incentivize users and hence created the feature for them to convert digital coins into real value charity donations. Furthermore, we aim to establish an online forum where users can provide feedback, request, and vote on features they would like to see. It also allows us to prioritize features to be implemented in future sprints and brings attention to undetected bugs and issues that need patching. The security of apps is becoming a more integral feature due to an increased risk of data compromises and breaches. Our application uses Firebase to store all data. Multiple security features are implemented by Firebase like two-factor authentication, varying user access levels, and data encryption. This ensures all our data is securely stored. Climate Collective is a global platform, allowing all First Nations people to contribute their feelings, findings, and knowledge about climate change. Our app allows First Nations people to have a voice in the climate change discussion and express their feelings, provide traditional knowledge about their land, which may be an effective strategy mitigating climate change, interact with others across the world with similar experiences. This is all with the aim to tackle UN Sustainable Development Goal 13, climate change, by contributing to Target 13.3 through improving the education and awareness raising on climate change by involving First Nations people into the discussion via our app.
Moving on to the project reflection, our team utilised the Scrum framework to base our development on pillars of continuous learning, being agile to evolving scope, and pushing out iterations of our product that had constant feedback loops integrated to deliver the most value for our end user. During the initial stages of our project, a roadmap was built out, segmenting the 3 sprint cycles with the high-level implementation milestones and best practice Scrum Management incorporated into the pipeline. Our team used the Atlassian suite to optimize Scrum ceremonies, ranging from sprint planning, daily Scrum, sprint review, and team retrospective. The Confluence board was our consolidated location for all key artifacts to increase transparency and horizontal communication. At the beginning of each sprint, a sprint planning session was conducted with an agenda to groom the product backlog and collectively decide which specific user stories would be included in the sprint. It was during this time where a lot of scope or requirement changes were discussed at length and factored into the new pipeline, such as when the team shifted from a domestic Australian scope to a global scope. Our team also performed a 15-minute daily stand-up to improve transparency and accountability across the board and provide an opportunity to clear any blockers. The Jira board clearly had an assignee and date for each user story and was regularly updated with comments. Towards the end of the sprint, we performed a sprint review where the MVP for that sprint was showcased, providing a great bridge for the business analyst to provide feedback or accolade for the developer's work. The final ceremony at the end of each sprint was the retrospective. This process was super pivotal in our continuous learning journey, as all members in the team had a chance to provide honest and constructive feedback that was rapidly incorporated into the next sprint. A lot of value was derived from this process. For example, a team member noted that our daily Scrum meetings were becoming quite lengthy and conversations involving only 2 or 3 people could be taken offline. From that feedback, a more specific agenda was created for each stand-up and any deviation was taken offline if required. While our team adopted an agile mindset, we felt it was also important to have key metrics in place to track and uplift our efficiency throughout the sprints. The front page of our Confluence tracked project health, green in this instance, and was a go-to place to see all the key achievements, next steps, and project risks or dependencies that needed to be addressed. We also had clear and defined sprint goals that were tracked in the daily Scrum and quantified in the sprint review. Our team used a burn-down chart presented at each sprint planning session and retrospective to create baseline productivity targets and pivot appropriately when we didn't hit deadlines. Using Scrum framework certainly came with its challenges, such as managing changing priorities and scope creep. Using quantifiable data points from our burn-down charts to drive our decision-making helped our team effectively manage scope creep. In our retrospectives, feedback was received about a lack of clarity in both our daily Scrum structure and finding project documentation, which was immediately mitigated through our transition from Teams to Confluence and consolidating all our artifacts and meeting minutes. Overall, some of the key lessons learned from the project was to adopt a fail-fast mentality and embrace iteration. Through the regular retrospectives and showcases, our team learned not only how to receive feedback, but also constructively develop others. We also learnt that the actual delivery does not always correspond to what was intended, so it's important to maintain that allowance for unexpected blockers.